Hi, in this video we want to show how to quickly and easily create a boundary scan test and run one using the JTAG Circuit Test software. And first we'll take a quick look at the test board that we're going to use for this project. This board has four Xilinx devices on it, JTAG devices. That includes one CPLD. The board has some DDR memory. It has some LEDs, some switches, which we'll use in our tests. And it is connected through a test access port via a ribbon cable to a JTAG controller, USB-based controller, which has two JTAG ports if you want to run multiple ports. And it runs at up to 30 megahertz. Before we get started building the tests, just for those who are not familiar with how boundary scan works, the concept is pretty simple. And what happens is that next to each pin on a boundary scan supported device, there's a cell between, a test cell between the pin itself and the internal logic of the device. So application signals can go from a pin through a cell into the internal logic and back and forth. For test purposes, data can be scanned in through a test data input port and scanned register style through each cell in this boundary register. And then if there are multiple boundary scan devices, the signal can be concatenated, so this output goes to this input through this path of boundary scan cells and then out through a test data out. So what happens is that the vendors of chips will supply what are called boundary scan description language, or BSDL files, that describe the implementation for their chip of boundary scan. That includes how the test access port is established, as well as how all of the cells in the boundary register are implemented. So getting back to the software, if we take a look, there's a controllers panel, and that shows you the USB controller that we just looked at, and it shows which tap pins. You can set the TCK rate on it, the location ID, and that type of thing. So from there, what we will do is we will go to the application button. We want to create a new test, and we will go to new project. And in this test, this is going to be the basic test for the software, where we don't have a project, or we're not using a project netlist, a CAD netlist. We're just using the BSDL files that have been provided to serve as the basis to create whatever testing we're going to do. So we browse to the project folder where we have placed the BSDL files, and that will be this folder. Select the folder. The BSDL files for the related devices are shown here. So without doing the netlist and all, we just continue. Click OK. And at this point, the software will come back and list the BSDL files that it found in this column. Now, we could drag and drop those files over into this JTAG logics list and put them in the correct JTAG chain order. And that's pretty straightforward. But the other way to do it is to simply click Auto Detect, and the software will interrogate the JTAG chain, and it has found that the BSDL files show up in this order. So what we can then do is add these detected devices to the logics list, which will be the chain. And these are the default reference designators that are assigned, but since we probably know our board, we know that the reference designators, what they should be, and we can simply edit in place, change these all, U2, U1. So if we had a net list, this is what it would look like when we were setting it up, but we're doing it without that. So if this looks to be the correct JTAG chain, what we then can do is click OK. And the software has now created in the circuits panel a list of the logics in the JTAG chain order. And we can click on one, let's say U3. It will show us all of the pins from that BSDL file. So here are the JTAG pins on that on U3. So for example, if we clicked on pin U8, we could go see what's connected to U8, and it's saying, oh, it broadcast a signal on this pin, pin 8, and it found that it was connected to these other pins on the board. So that's just to get started. But before we go too far, let's do something. Let's go over to our list of components and go to net, list them in net order versus logics order. And the reason for doing this is if we can identify the ground and power nets, even without the net list, it's a good idea to do it so that if any boundary scan pins are on those nets, we won't be trying to drive them. So we'll list the grounds, for example, and we will assign the ground nets, and the same with the power nets. We'll list them. And these are in order of pin count, since normally the power and ground pins have the most pins attached. So we'll just go with these for now, and we'll assign these to power. There may be more. But so once we've done that, let's go in and just run the test on all the pins. We have a chain. Let's see what happens. And the test runs. Now, since we don't have a net list, we don't know what should be connected to what, but these red dots indicate that the software, in broadcasting from each pin and looking for the signals on other pins, it has found some connections, and it's asking, you want to connect these. We could check out these one at a time. For example, we could take a look at this pin and wiggle it high, wiggle it low, and we see, this other pin, it thinks R1 is connected to P1 on device U1. So we could go through in here and say, yeah, connect it. And we could do it for all the pins, but rather than do that, let's do it this way. Let's go through to learn trace results and see what that gives us. We'll run the test again, and it passes. So just how good a test do we have? We've probed the board throughout using the boundary scan pins. So let's insert a fault. We'll do that by connecting a pin. So with this test, I'm going to flip one of the switches on the board to insert a fault, and then we will run the test again. And so what it finds now is that this pin, U1 pin T7, is failing, and it should, because it's connected to one side of that switch, which was just flipped, and it had been learned in the opposite state. So in this way you can see that you can develop a test pretty quickly, and you can do some diagnostics if there are faults from what you believe are the correct connections. Those those will show up pretty quickly by just rerunning the test. So there are some other things that you can do which we'll treat in another video. For example, setting guards on pin. You can customize the test quite a bit to set guards on pins that are controlling parts of the circuit that need to be constrained. But for now, we're going to leave it right there, and we'll continue with the next video. In this video, we are going to show how to build a boundary scan test application using JTAG Circuit Test software. And in order to do that, we are going to use a test board. This board is a Xilinx eval board, and it has 4 JTAG devices, including a CPLD and a JTAG chain. It has some DDR memory, it has LEDs, switches, and is connected via a test access port and a ribbon cable to a JTAG port on a controller. This is a USB controller. It's called the OnTap controller because it's used with the Flynn Systems OnTap software. Runs up to 30 megahertz. It has 2 JTAG ports, so you can run, say, 2 JTAG chains on the board, and if you have more than that, you can run multiple controllers, as many as you need. So we also want to take a look at just what is boundary scan for those who may not be entirely familiar with it. The concept is that we can scan data in through a scan path and use that to test our board. And in particular, if you look at the implementation on a board, there's a JTAG cell, a boundary scan cell circuit that lies between each physical pin on a board and the internal logic. So when the board is normally running, these cells are in effect transparent. So signals can come in from a pin right through the cell and into the internal logic and back and forth. Once you're in boundary scan mode, you can switch using the tap and signals on the tap, test access port. You can scan data into these cells. It's serially and along this register of cells. You can connect devices, test data out to test data in. You can connect as many as you'd like until you finally go out, test data out. And once you have signals captured in each cell, say in boundary scan mode, you can then use that. Those will be broadcast to other cells connected to other pins on your board, and you can transfer. Once you run a test, you can then capture signals back into these cells and then scan out the captured data, and in this way you can do a structural test of your board. These cells, the implementation in each integrated circuit is described by what's called a boundary scan description language file, BSDL, and these are made available through the vendors of the chips and typically on the websites of these vendors. So in order to get started, what we will do is go to the application button on the user interface upper left and click on that, and what we're going to do is open a new project. and we will click on project folder. This will be where we keep all of the test data. Select that folder, and it will show us that in that folder, and this is all we need to get started for this application, are the BSDL files for each of the 4 boundary scan devices on the board. So here they are. We have them, so we can click OK. Just to mention, we're not using a net list in this application. The next video will show how to do this all with a CAD net list, but we're not using that. We're not using BOM files, just the BSDL files. So we click OK, and we now have a list of the BSDL files here. So in order to build an application, we need to define the JTAG chain to the software. And we could do that by dragging and dropping these files into this JTAG logics column and ordering them test data in to test data out. But to make it easier, we're going to try auto detect. So we'll let the software figure it out, and it shows test data in through this device and its representative BSDL file, and then through the other devices, and then out through this FPGA. So this is the test data out end of the chain. What we can now do is take that detected information and move it over into our column, and this is the JTAG chain column. The software has assigned some default reference designators, but since we know the actual reference designators for these chips on the board, we can edit in place. So we'll do that. So this should be the JTAG chain, and it is. So from U4 test data in to U1 test data out, and so we'll click OK. And the software will build a model and show it here. What we want to do next before we get started testing is just make sure the controller is set up correctly. JTAG chain A, port A on the board is connected to JTAG chain A. Here chain B is shown as none because we don't have a second chain. If we did, we could call it B or whatever we'd like. But we're going to save this configuration. That way our controller adapter is matched to the JTAG chain configuration on our board. So we're ready to go. One further thing we could do is test the tap. We use the tap in order to detect the chain on the board. So we know it's working to some extent. But since that's our primary test instrument, well, it's embedded in the board, but it's the test instrument, what we're going to do is create a test, and then we're going to run that test. So when we run the test, it's going to do some additional testing of the tap, the pins on the tap, TCK, the clock, TDI test data in, TDO test data out, TMS test mode select. All those are going to be tested. And it's going to check the boundary register length. So this is making sure that all the cells that we're going to need in order to do our boundary scan testing are in fact there and connected. So based on the BSDL files that are connected together, we're expecting 2,295 cells, and we measured 2,295 cells. So our basic test instrument, the JTAG chain, is working. So now what can we do from here? So the next thing to do is we want to test all of the pins. Let's show the circuit. We'll show the circuit. For example, we click on a pin here, a device here, and then all of its pins are shown. So what we're going to do is we're going to test all of the pins. So what has happened here is that the software, it's not using a netlist, so it doesn't really know what's connected to what, but it broadcasts a signal on each of the pins, each of the output pins, and I/O here stands for input output. So for example, pin R1 on U1 sent some signals out, and P1 captured those signals correctly. So it's asking, do you want to connect those signals? And here we could say connect to this pin, and we could go through each of these pins this way, but it might take quite a while. There are quite a few pins. Or what we could do is just click learn all of the results. And so it has learned the results. We could then, actually what we could have done before that is even to test each pin, we could have selected a pin and then wiggled it back and forth and checked that the other pin followed it. But what we're going to do now is we've learned the pins, and we will then rerun the test. So it's still showing some failures, and